You keep it in a virtual environment, isolated from the internet, from everyone, and it serves as an oracle. If you have any questions, it's able to answer questions, but not directly impacting the world. Back then, the thinking was that's what we're going to do in our research labs. Not so much. Last year, we released those systems, connected them to the internet, gave personal access to everyone who wants it, and if that wasn't enough, we open sourced code from some of the labs. So the whole area of research is gone. They never broke out of a confinement box. We just let them out.
Hi everybody, my name is Ryan. I'm here today with Roman Yampolskiy, who is an AI safety researcher and a lead thinker on mitigating risks in advanced AI in the United States and globally. Roman, I'm really thankful to have you on the show today. It's a lot of the conversations we've had in this show have been on pathways to benevolent AI. A couple of years ago, and then increasingly about 6 months ago, really started to look very closely at the scarce opportunities that we had as a species for realizing superintelligence that had some attributes of benevolence or altruism. This is maybe a Sisyphean task, and I feel like there's an enormous opportunity for the community of people who look to artificial intelligence and advanced artificial intelligence as a panacea, as something that can solve lots of problems, to understand the full width and breadth of risks associated with sort of nonlinear advancements in capability in the field. And so it's a real pleasure to have you on the show. And I would like maybe to open by inviting you to tell our listeners a little about your forthcoming book, what's coming out here in the next 6 months, you say? And what are the maybe 2 or 3 central themes that are really driving that piece of work?
Right. So I'm an AI safety researcher. I've been working on it in at least partial capacity for about 10 years, probably last 5 years full time. And a lot of my work is on theoretical limits to what is possible in this space. Can we control superintelligent machines? Can we understand how they work? Can we predict decisions they will be making? And there is quite a few others. And the book is kind of a culmination of all that research, very non-technical, accessible way of sharing my findings with the broader community.
I'm really interested in this question of seeding AI, seeding advanced AI, and seeding or pre-training or leaving breadcrumbs in the ether for emergent intelligence to have certain characteristics. What we do and the way that we, and I mean as an economy and as a society, across the internet, across the economy, sets a foundation for artificial intelligence to be trained and then ultimately to train itself. Maybe I could invite you to share some of your thoughts on the opportunities and maybe some of the limits to the opportunities for preceding or pre-training some future singularity.
So right now it looks like we're training on all the data, right? We're basically trying to get as much of it as we can, all of the internet downloaded, every book, every encyclopedia, so there is not much filtering. You're really getting all the good stuff and all the terrible stuff off the internet. So once the model is trained, there is this process of putting lipstick on a pig, essentially. You add human feedback, you try to make it not rude, helpful, reduce unhelpful behaviors, increase helpful behaviors. And that is also a biased process. Who decides what is helpful? Who decides what is permissible? So you have this initial monstrosity trained on the internet. Now it's a little more friendly, kind of civilized. We told it, okay, don't use that word, don't insult people this way. But we are not fully controlling its behavior. There is also a possibility, we saw it previously with, for example, Game of Go, where all the previous human knowledge is initially taken to learn how to play the game, but a later model ignores it. It's zero knowledge model. It learns from first principles what the game is and how to beat it, and it's superior to all humans and to the previous model. Maybe we'll eventually be able to do intelligence without human training data, just from self-interaction, self-communications. That's also possible.
The emergence of zero knowledge, self-training intelligence that is superior really renders a lot of the conversation about what can we do now rather moot or not. And so maybe, I as an optimist, from time to time, I find myself hopeful that the sum total of human records actually reveals something positive about the species, or something innately altruistic or justice seeking about the species that might find its way into the DNA of some emergent superintelligence. But I recognize that that might be a pipe dream. And I wanted to invite you to reflect or share some of your thoughts with us about where you see some opportunities for creating species of AI, or where you see certain configurations of value sets emerging in AI that, based on the sectors they're coming out of, or the countries that they're coming out of, or the configurations of training data that they're coming out of, that those configurations of AI might have certain characteristics, positive or negative.
So that's actually a good question. I never thought about it. What percentage of human-generated knowledge is actually positive versus kind of really negative and neutral? That'd be an interesting research project to undertake. If you look at overall production of humanity, are we mostly benign, altruistic, or are we producing a lot of horrible things? In any case, obviously, there is going to be some of it good, some of it neutral, some of it bad, and how the mix plays out is not obvious. Again, if you're training on all of it, any model you train would end up kind of converging in the same knowledge, same capabilities. It's that secondary step of filtering it out, shaping it, giving it feedback, which would decide what culturally it's like, what politically it's like, and we're starting to see it. So a lot of kind of bias introduced, maybe politically more liberal, because a lot of people designing those systems, maybe from San Francisco, this is kind of what the normal is in that region, right? So we're starting to see how the system responds to questions about one party versus another. If a system is developed in China, they're not going to tell you about certain political events. They're not going to badmouth a party in power, and so on. So you have to keep track of who is doing the filtering.
Sometimes I feel like we're in a very prototypical phase with this technology, in that humanity is still enjoying an option to set some of the rules, and enjoying an option to set some of the access. How long do you think, this is a softball, this is a silly question, but how long do you think that period of time will last? And I will bookend that by saying that the assumption is that at a certain point AI is meeting itself loose in the wild and training itself or interacting with itself, independent of constraints placed on it by programmers. But we're not there at the moment. And so I want to get your take on how long you think it'll be until the trainers are no longer really driving the narrative.
So that's a great question. That's the open research question. Can we actually guide it towards specific spaces in morality and ethics? Can we instill specific values? It's still an open question. It seems like it's not something we know how to do today in terms of a fundamental model. Again, filtering is something we can probably do. Once we get to human level, and beyond AGI and superintelligence, it probably is too late. So the question really becomes how long before that level of capability. And there is, I think, prediction markets saying maybe 4 years. Heads of top labs, DeepMind, Anthropic saying 2 years. There is some insider information saying maybe we are actually closer than that, maybe next year. So we don't have a lot of time, and the problem is super difficult. We don't really know if it's solvable even.
Assuming it's not solvable, imagine if we were on deck when we were building the first nuclear bomb. And we understood that the science of atomics was moving forward despite our objections. At that point in history, 60, 70 years ago, people made a great deal of effort, it's been a long time, to start to apply some safeguards, social safeguards around the outside of the technology. Maybe you could share with me your thoughts on 2 or 3 very important safeguards that can be applied around the edges of the technology now or in the next few years that you think might buy us some time to understand what we're working with, or otherwise shift the trajectory of the technology in its infant period to one that is more benevolent or less destructive?
So the best option would be if, for personal self-interest, all the top labs decided we're going to pause developing more capable systems until we have a safety mechanism in place, which we know we can test, which scales to any level of capability. Basically, a good decision not to proceed with something you cannot control. Right now, we have this arms race between different labs trying to get there first. So that's problematic. If that's not happening, the other alternative is to do it through governance, legislation of some kind. Problem is, you can make certain things illegal, and if a company violates the rule, you can fine them for it. Okay, but that assumes that what we're doing is some sort of a mild problem. The algorithm is using private data, the algorithm is discriminatory, you can punish them financially. If we're talking about super intelligent systems and existential risks to humanity, you're not going to punish anyone if everyone's dead. At that point, it's a little too late. So there are limits to what governance can accomplish.
That's fair. When we think about so when we think about opportunistically those patterns of use, those patterns of training that might be forming the foundations of AI that might have other characteristics, maybe a little less malign, a little less willing to annihilate the species that came before it. Do you feel that there is any relative potential between, say, AI born out of the medical field versus AI born out of a military field that might shed some character or some personality, some values, some ethics that are different into different species of AI?
So we know that narrow AI systems can be steered and controlled much better. So if you have a medical type AI, protein folding, something like that, we're pretty good at figuring out what it's going to do, controlling that. The moment we start talking about general capabilities across domain, the initial training data may kind of be a big part of it, but it doesn't guarantee final outcome. If it keeps self-improving and learning from all the other data it has access to, it's still quite problematic. So if we manage to take all the training data and clean it and filter it and make sure it's only factual, high quality scientific data, that would be helpful, probably starting point. But again, as long as it's a continuous process of rewriting its own code, learning from new information, running its own experiments, I think at some point it converges to the same knowledge base just because you have only so many options for obtaining information. It's very hard to keep a general intelligence from learning facts outside of its domain. You can see it with humans. Maybe somebody's raising kids in a certain religion. They grow up after 18, they discover this new religion and messes up the whole family. So it's likely that you cannot contain general intelligence to a domain-specific knowledge base.
Granted, I think that's pretty clear. Maybe for those of us in the audience who our knowledge and our understanding of self-improvement, of iterative self-improvement and AI rewriting its own code, we understand those words. And I think many of us understand it as a concept. And yet, in some contexts, that's already occurring in the tech. And I was wondering, or I believe that might be the case, you know better than me. Could I invite you to maybe give us an update on 2 or 3 examples of self-learning AI today that you think are pretty cutting edge, where we're seeing this sort of iterative self-learning, self-teaching dynamic, moving past sort of the standard machine learning models that we might have had of sort of picking a better mousetrap, but actually rewriting a better mousetrap to be a house. In say the last year, what's really cutting edge? Where do you see the real driving pace of change?
I don't think we have truly self-improving systems yet, where the system does science and engineering and rewrites its own code. I think we have systems which can write some code, segments of code, which can look at code and maybe optimize it, but it's a one-time deal. It's not a recursive cycle of self-improvement. In terms of learning, systems today can get access to new information. You can tell them, read this website, read this book, read this manual, learn from that manual new information and apply it in this domain. That's standard human level learning in many domains. I think the new models we see advertised, multimodal models, do it now with images, with sounds, with text, with video soon. So it's very close to what we expect a human employee to be able to do. You start a new job, we give you, guidelines for working here, you read them, and hopefully you can start helping out.
How about tasking AI to manage its own ethics? Are there opportunities to have the guardians be the guardians of the guardians? Do you see any opportunities or where are the opportunities emerging now for employing AI? I mean, this just touches on the arms race concept. Using AI as a tool for either making better data sets, removing sort of the most antisocial components of the body of human knowledge. Are there endeavors being considered or deployed in the United States to employ AI, nascent AI, to clean up the workshop so that it is a better place for the next generation of learning models?
So you have this very difficult problem. What is good? What is bad? What is ethical? What is moral? You're saying we can't figure out how to do it with this AI. Let's create this other AI who's going to monitor this one for that. You're just shifting the problem around. You're not solving anything. If you're talking about censorship, yeah, Twitter, Facebook, they have those algorithms for filtering out truly the worst stuff, but who decides what is the worst? A lot of it is just censorship of political opposition, censorship of what they disagree with. It's not truly any good or bad material, it's just disagreeable material. So I don't think we're at the level where we know what information to give the system to police the other system. And to expect it on its own to come up with what is ethical will definitely give us problems.
I appreciate very much that observation, which we've seen over thousands of years, of power shaping narrative, power shaping a body of knowledge, power censoring information between generations. And in this case, what I find fascinating about AI is that generations could happen quite quickly. And that we're coming up on this rapid acceleration of that generational shift as one generation of AI is retraining another. You followed this emergence of AI toolbots contracting with other AI toolbots to do small pieces of work. Can you share with me a little, like, do you follow this space at all of like using AI to take jobs, break them into smaller pieces, and contract with other elements of other computer programs run by learning AIs in different places to deliver on that piece of work, which is a contract, which is an economy, which is trade, which is a different organizing mode than problem solving, studying, learning, critical thinking, and deploying a knowledge model. Now we're talking about actually solving a problem through contracting. Is this a space that you feel might produce a different pattern of learning or a different value set from the more zero knowledge learning models? Is there something special about contracting or markets for solving problems among AI that might lead to a different set of outcomes or a different set of risks?
So this crypto economy with smart contracts, it has advantage of being more mathematical, less ambiguous than human language. So you better at agreeing with another agent. You can verify contracts better. Some people think we can have proof-based safety in crypto space because everything is verifiable. There are limits to that. If you want to interact with the real world, you need oracles bringing information from the real world onto the blockchain. And that's where problems begin. You have sensors which you can manipulate. You have kind of democratic voting where 51% is democracy. It's also an attack on 49% minority. So it's a good environment to experiment with. It has obvious benefits for internet economy, for economy in general, but I'm not sure it gets us to the solution for controlling superintelligent agents, just because they are essentially hackers or super smart lawyers who will look at your contract, just like human hackers do today, find an exploit and drain all your money out of it. It's like any other piece of software. It probably has bugs.
I don't know if that's quite the outcome I was hoping for. Again, there's this dream of being able to decipher, draw out from the community what are those pathways that might be identified and pursued to create more benevolent outcomes, more altruistic outcomes. And they're few and far between, right? Obviously, it really sounds like in seeding AI, and in understanding that learning models are digesting a lot of data. So it's really there's a real active conversation about, well, what is the nature of that data? Altruism and ethics, whether or not those are also shaped by power, that's an ontological question. I don't think we're going to get that deep today, right? But it always struck me that the quality or the earnestness of justice seeking or altruistic training material, that had some potential. These questions about whether contracting and markets of exchange have any ethical characteristic structurally that might inculcate an ethic in a superintelligence, it still seems pretty ambiguous. In your work in talking about pausing AI, pausing development, and maybe we can have a sidebar on this topic. How, and you're not alone. A lot of really, really intelligent people are raising their hands and saying we really need to pause development. And do what? Pause an arms race and give us time to do what? And I want to just maybe invite you to clarify, to edify, to teach our audience about what are the 2 or 3 things that really need to be done in that hiatus. If we could get a 2 or 3 year pause, what are the 2 or 3 really important things that need to be done during that time before the market economy could get back to work trying to drive profit by driving technology?
So I think it is a mistake every time community is asking to pause for a certain amount of time. Like we had the 6-month pause, which expired, I think, this week. Why 6 months? Nothing specific happens on that date. It's pointless. Pausing is capabilities based. You're asking, until I have this capability, no more capable systems. Capabilities I want. You are able to explain to me how your system works. It's not a black box. Every neuron, every connection, you can tell me what it does, what it's doing, what it's going to do next. You can explain your design. You engineer who made the system, it shouldn't surprise you. We should be able to predict what decisions it will make in different situations ahead of time. We should be able to monitor those systems while they're training, at deployment. I should know right now what GPT-5 is going to be capable of doing ahead of time, not training it for a year and then testing it for next 10 years to figure out what hidden capabilities it has. Until those tools, those safety mechanisms are available to you, don't make more capable systems. What we have today is incredibly powerful. It's smarter than most humans already. You can monetize it for the next 50 years, have amazing life. You can have narrow systems to solve important scientific problems. You don't need to have superintelligence next year. There is no reason for it.
It's a very, very good point. Thank you. Right? There's it bears repeating that the advances of the last 3 years have been so intense. The economy and slow-moving humans and our capital stock, we haven't adjusted. There's an enormous amount of latent value right now that has not been incorporated. It certainly hasn't been priced in effectively into the economy. So there's a lot of work to be done there. So that's a very good point. That there's a lot to be done with what's been developed so far. So no need to race ahead into the great unknown. Take a little time and actually work with what you have. My daughter is 8. If I was told to have her stop growing up until I could predict her future and understand how she thought, it wouldn't work out for me. And I believe she's a superintelligence.
Do you think you control her?
Yeah, well, a lot of people are going to respond that way. It's a false metaphor. And so I want to invite you, who's had that conversation around campfires many, many times, to explain to the audience why that's a false metaphor. Why that thinking of, well, I don't want to stop my kid growing up just because I can't predict what she's going to do after high school. Why that thinking is a false parallel, or why it might be, and what risks sit behind that kind of thinking.
So you see the general pattern. The more capable your child becomes, the more independent they are. The baby is fully controllable. You place it somewhere, it stays there. You are completely determining what it's going to do. At some point, it learns to crawl. Now you have to keep track of it. Maybe it escapes. Then you have teenagers. God knows what they're going to do. The moment they turn 18, they're independent agent from you. You are not controlling their life. They can do what they want. Hopefully, they're a good human being. That's the best you can hope for. Some parents get very disappointed. Their kids grow up to be serial killers, maniacs, monsters. Maybe they were good parents. They didn't program it in. It's just something in the hardware or software or interactions was not accounted for. And let's say they're very unlucky. It's a monster. They go on and kill 5 people. That's terrible. But their capabilities to cause damage are limited. They're not going to kill 8 billion people, no matter how hard they try. This technology can. That's the difference. You're creating an independent agent, not a tool. Narrow AI is a tool. General AI is an agent. An agent which is likely to be smarter than you. So whatever it decides to do, for game theoretic reasons, for evolutionary reasons, if you're not predicting it, if you're not anticipating it, if you have no idea what's going to happen, you are placing yourself in a very dangerous situation.
This idea of the precautionary principle as a couple of words to describe a whole lot of heavy thinking seems to sit at the foundation of a lot of the arguments being put forward for a pause in AI development at this stage. And as a leading voice among many very intelligent leading voices for a pause in development, I do want you to take a minute and explain how the precautionary principle drives the logic of the thinking, right? What it means to you, and what it should mean to decision makers in government.
Right. So the question is, you're trying to balance benefits versus potential costs. If you get this technology right, it's benevolent superintelligence, you win. You get free labor, physical, cognitive, you're talking trillions of dollars, hundreds of trillions. You're talking about scientific breakthroughs, medical breakthroughs. You cure cancer, AIDS, aging, you have immortality, you have free stuff, you have super entertainment. Life is pretty good for you. So the payout is amazing. But if you get it wrong, you lose everything. So how much would you be willing to gamble, and at what odds if it was your life on the line? Would $1 million at 50-50 be a good bet? $1 billion, 10% chance of losing? We need to ask 8 billion humans to consent to this experiment. Most of them don't even know this is happening. There are people deciding what's going to happen to humanity as a whole. They, in their public communications, blog posts, tweets, agree that technology is extremely dangerous. They don't know how to control it. They cannot predict what it's going to do. And basically the logic is, the money is really good. Let's get as close as we can to the danger zone, and we'll stop then. We didn't stop today. We didn't stop last year. But that second where we sense that it's about to go for final solution, we're going to stop. All of us will immediately stop research, and it's going to be fine. No malevolent actors, no leaked code, no unanticipated capabilities from earlier models. It's just going to be a perfect outcome. That's somewhat unrealistic.
You've written about leaks and superintelligence. This is a topic that you've touched on at some depth in your work. But it was some time ago. I mean, you started working on leaks and superintelligence a decade ago. And, yeah. Safeguards and security around code base has improved. Nuclear codes don't fly around on the dark web. We do have, you think, we do have a history as a species of keeping secrets and keeping safeguards in place. Where do you see the strength? Again, I gotta find something optimistic to talk about here. Where do you see some strength in, or some emerging capabilities that give you some faith, if any, that the patterns of securitization that we've developed as a species in a market economy can help, or are making a difference in reducing those risks? But also, please take a moment and talk about those risks.
Sure. So you're right. It was over a decade ago. I published this paper in 2012 on how to keep powerful AI system boxed. You keep it in a virtual environment, isolated from the internet, from everyone, and it serves as an oracle. If you have any questions, it's able to answer questions, but not directly impacting the world. Back then, the thinking was, that's what we're going to do in our research labs. Not so much. Last year, we released those systems, connected them to the internet, gave personal access to everyone who wants it, and if that wasn't enough, we open sourced code from some of the labs. So the whole area of research is gone. They never broke out of the confinement box. We just let them out.
Okay.
We gave them internet. We gave them plugins to operate with our software. We have API access. If you were trying to destroy the world on purpose, I don't know what else I would do. I'm running out of ideas to make it worse.
Well, that's a hard one to follow up. Okay.
That's what happened. That's
Yeah,
the
I
reality.
watched too. We all saw this, this, the and yet that is the massive uptake of the economy, and that's the marketplace of ideas and innovation, and that's where lots of folks are now employing those tools in their daily lives in interesting and new innovative ways. But maybe it would also be valuable to elicit your sharing on how it lifts off. And so those of us who are looking seriously at a hiatus or a pause and saying, okay, a pause in the arms race is a desirable thing. A moratorium on something. I'd like you to fill in the blank. It's a moratorium on what? And I think that would be helpful. So let me just ask that quick. In terms of a hiatus or a pause, what would a moratorium do? What material behaviors or types of investments, types of researches are the ones that need to be paused most quickly and for potentially the longest period?
Don't train larger models, more capable models. So let's say we take GPT-4 as a given. That's what we have right now. Don't train a bigger model on more data with more compute, with more modalities. Practice with what you have. This is available. Everyday papers are published about new capabilities of that model, limitations of that model. Keep studying it. The reports are that it's, let's say, 84% aligned, whatever that means. Well, can you get it to 100? Then you get this one to 100. We'll talk about the next one. If you can't control a dumber system, why do you think you're going to do better with a smarter system? The reports on how aligned it is are not reported in actual numbers. They're reported as a percentages of capabilities. If the next model has 1,000 times more capabilities, but it's 2% more aligned, it's less aligned. You're just reporting the wrong data. It can fail in many more ways. It's dangerous in many more ways.
If you could task those models, if you could task AI, if you were able to, let's say, in a perfect world of being able to apply regulation and say, these things, all of these things for X periods of time are off the table. You're not going to do those things. What would you leave in place? What are the areas where you would be comfortable with AI continuing to advance?
So we have interesting narrow AIs for specific projects. I think protein folding was a great example of a success story. The system is super intelligent compared to any human scientist. It accurately predicts how the protein model will fold. It allowed for essentially brute forcing all relevant biological proteins in humans and maybe animals. Amazing result, amazing results for science without any concerns that that specific system will take over anything. It's not designed to be general. It has a specific purpose. You can do the same in other domains. We saw it done with Go, with chess, with so many specific applications where you have a system, it knows one thing, it knows it well, it's a tool. It's a tool which helps people. Why do I need to create a manager level AI which can do everything at once? And
That's really helpful. And I'll nudge on it just a little bit longer, and then we're probably headed towards the end of our conversation for today. I want to maybe invite you to reflect with me on some of the tasks that might, or some of the activities that you think might provide a nice learning environment or a nice evolving environment for advanced learning models. And I oftentimes, as I think about medicine, right? Medicine is fractally complex. and it, yeah, you can work on subanatomical and subcellular systems for a very long time and not get bored. They're deeply, deeply complex things. Are there areas like medicine that AI has an opportunity to do a lot of good work at a lot of great depth without entering into maybe contact with the entire world, maybe being loose in the wild, or achieving or seeking to achieve general intelligence? Um, uh, Medicine is one. We'll look at that in some depth in this show. But are there some other ones where you're really excited about what AI can do now and where AI today is already creating a lot of positive change?
So I think basic scientific research could be something we can have targeted systems. So a specific problem in physics, not general understanding of everything in cosmology and building artificial Einstein, but you have a specific problem, you have data for it, you're running out of ideas for how the data fits the model. Maybe AI can give you some multiple choice options you can select from, guide your research, work together with a human expert to improve on those experiments, design better experiments within that narrow domain. So it's an expert in something very specific, like a PhD student is very narrow expert. It's not an expert in all of humanity. That could be something. I am at the same time very concerned that a capable enough system, even in a narrow domain, can still be very dangerous. Let's say we talk about chemistry, design of new molecules. Some of those molecules are poisons. Some of them can be used for chemical weapons. So even within a narrow domain, you have to be careful about how this tool being utilized by malevolent actors.
Roman, you've done a profound job today. Thank you very much in helping us understand the range and the contours of the risks across the space of rapidly emerging AI capabilities on the pathway to general intelligence. Thank you for that very much. What are the questions that are burning in your mind that you're hoping are answered in the broader scientific community, in the AI community in the next year? What are the questions that are keeping you up?
I'm wondering if I'm right or not. So I published maybe a dozen papers saying it's impossible to control those machines. I don't see sufficient engagement from scientific community. Show me I'm wrong. Prove me I'm wrong. I'll be the happiest person in the world. But you have to address the arguments. You have to do something. Right now, basically the approach is we'll solve the problem when we have it. Yes, nothing is working right now, but I'm sure we can figure it out if we put enough money on it. Give me $1 billion and an island full of scientists, I will solve it for you. I don't think it's a good approach to this problem. So again, engage with limitations I'm bringing up. We're starting to see some engagement. Some companies are saying, oh, there are those pessimistic scenarios. Maybe there is 15% chance superintelligence is uncontrollable. But they don't update based on that possibility. They continue doing the same research, obtain additional funding, continue making systems more capable. Every time you release a model into the wild, there is a possibility that someone very smart will make it 10 times more capable by making small manipulations, not necessarily retraining a whole new model with lots of compute. That's a possibility. So take this problem seriously. Address worst case scenario. That's a standard approach in cryptology. It's a standard approach in complexity in computer science. If you can deal with the worst case, if the reality turns out to be nicer, maybe superintelligent systems don't care about us. Fine. Yeah, you're guaranteed to win that way. You already know how to handle worst case.
Well, Roman, you blew the top off my head today, and I enjoyed that immensely. I think a lot of the audience learned a lot speaking with you today. I'd like to follow up with you on a one-to-one because there are a couple of things we've said today that I think are really worth an extra exploration. Thank you very much. I think we're going to wrap up. And yeah, it's a real pleasure to have you on the show. Thank you for joining us. And the next time, I hope we have an opportunity to dive even deeper into the successes that we are seeing around the margins for unlocking the value that AI has today, not in a general intelligence model, but right now, for creating lots of advances in human experience, market economies, and human health. Thanks. I think you've made a strong case today that we've got a lot of value on the table and that there's a lot of value to be enjoyed for the advances that we already have in hand.
Thanks for inviting me. I appreciate the opportunity to share with your optimistic, benevolent audience.